So thank you for that introduction. So my name is Chandler Gruener. I'm a extension soil health specialist. I'm located in Minot at a research center. So just doing a little bit of outline here, we'll do a little soil and water background, strategies to improve structure, about plow pans and plans to help out with wet areas. So being a soil scientist, I just like start off a little bit of background on like soil series. So we look at soil series as like a history book. And so out here, we got Fargo and Williams, two of the most common. They're on your far left and far right. And then in the middle, you got soil series associated with wet areas and fields. And so what you notice a common theme in all of them, there's a G. The G refers to glaying, which is a gray color. So you think about it as gray, G. So a lot of times that's evidence of water. So like I said, it's a history book soil series. So if you have gray in your soil, it's history of seasonal high water tables, frequently a lot of water, ponding and standing. So a lot of times you'll find that in your troublesome wet areas. And so just a little more background here is like, so physical samples can be hard to take and figure out how much water your soil can hold, how well the water is going to go into the soil. So soil science, we look at like different soil structures pictured here along the bottom. So some of the different things that can impact is continual plowing or tillage can oftentimes you can get that platy hard pan layer if you ever dug down after a lot of tillage over a long time. You can find some platy nature. Sometimes it just comes so solid the water goes down, has to go sideways until it finds a relief spot to go down. Oftentimes when you have chemical aspects of like salinity or sodicity, you can actually get structure where it creates columns in the soil and the water actually just flows straight down. It doesn't do super well with like actually moving around, it just flows straight down. And then also you can get crusting on the surface, preventing your water from even moving into the soil, also creating these wet areas. So soil ideally we made up here, you can see this pie chart, 45% mineral matter. So here's sand, silt, clay, organic matter, ideally 5%, and you'd have water and air making up the other half. So realistically, sand, silt, clay is not something you guys can change, but organic matter and then amount of water and air in the soil is something that can't be altered. So organic matter, the reason why it's important is it provides binding locations. So right here, I went out this summer and went to a field where they've been doing some practices to help build organic matter. And then they had the other half of the field where they weren't trying these new practices. So down here, you can see there's actually kind of hard to see on the screen, but there's a little pebbling forming. So the soil is actually binding and forming aggregates. So down in the soil, when you form aggregates, it actually helps with water moving into the soil and being held in the soil because it provides these binding locations for the nutrients, water molecules. And this is all from increased organic matter, something that can be measured to see if they're actually getting those results. So water infiltration, another thing, key way to see like how you're improving or changing things over time. And so here I went out and put blue dye on the soil surface, poured water and let it go down. And then right here where this bubble is, it actually hit a limiting layer right there and it started moving around and find different channels. This darker blue spot right here, I'll just point to it. This darker blue spot is actually following a root channel. So using cover crops or roots that are allowed to fully work their way down the soil and get all the way down to full depths can actually create better movement of water into the soil and help break up some of the limiting layers of plow pans using natural means from biological like plants instead of using tillage. And so water infiltrating, here's just some images, like we dug a pit down to 60 inches. So we just poured water on it. Right here, we have good aggregation and then actually the water moved down really well. Here's an alfalfa root making it down to 60 inches. And then we have some wheat stubble right here that was making it down to about 20 to 30 inches a lot of times. So all these roots are helping build this, form this aggregation and actually allow the water to move into the soil. And slowly over time, we've been building this organic matter, creating the higher water holding capacity. So that's the amount of water we can hold in the soil. And so we've been influenced this by increasing our organic matter at the sites to improve the structural capacity. Bulk density. So owners, so we're back to that pie chart here. We got the mineral matter. So there's mineral matter has actually been reduced. And so in areas like here in this column, this sodic soil. And so sodic is a high sodium content in the soil. So it actually kind of decrease the soil structure. So it wasn't tillage, it wasn't anything that could really help do the producer. It was just the sodium was really high in the area, and there wasn't any way to lower the water, get the salts to drain out. So slowly over time, the bulk density went up and up. And so the bulk density was getting the 1.6 to 1.7 range because of the sodium in the soil. And so the bulk density was another indicator that there's something going on. And we eventually went out there and did some chemical analysis we'll talk about here in a minute, figure out what the source was. So here's that same core, but I just zoomed in a little bit so you can see the sodium right there building up. And so sodicity affects structural performance. So some of the strategies to improve the soil structure. So tillage with a purpose is what we always recommend to soil scientists at NDSU. So we understand tillage for different reasons needs to occur to help do different things. But reducing the tillage and kind of picking selective times when it's not as wet out there, because if you're tilling when it's wet out there, you can actually create plow pans down below. So that's some compacted layers I was talking about. And then your water hits it, it has to find a way to go around the plow pan and get underneath. Strip tillage is one technique that some people have used to help kind of vary from year to year. They alter their strips they're tilling to help build them aggregates up and reduce things. And then if you are going to do some tillage, try not to leave the ground uncovered for long. If you're going to till in the fall time, try to leave it very chunky and big pieces. So that way you don't have as much erosion. You're not blowing away your organic matter and your fresh new residue that's trying to work its way into the soil. And then come back in the spring with your crumblers and stuff and try to break it up a little finer. Cover crops is another way you can help out. So planting cover crops in the fall, I know it can be very challenging. By the time North Dakota, your season is still short, can't actually get out there with cover crops a lot of times. So I'm going to talk about some strategies later on that can help with that. So here's just a little bit of soil moisture story about why some of these cover crops can be beneficial. So we came up with oats here, and this is in Minot. So we go from August 19th of this year to November 20th of this year. On the left axis over here, we got water potential. And so what you can think about here is the closer you are to the top, the closer you are to saturated. 0 be fully saturated. Here's about dry down to 110. And then on the right is the rainfall. So we had a big rain here about September 16th. And you can see the area. So green is cover cropped. 6 is the top one, 12 inches is the bottom, and then non-cover cropped is the orange. And so where we had the cover crop growing, so this is only 1 year of cover crops, we actually seen a nice water infiltration increase from the rainfall. And then we always got asked that question, like putting these cover crops out. And so what we did is we had to come off of oats. And so we harvested very early, obviously. We were able to get the cover crop out there. We were able to actually get some growth, but realistically, this camelina was only about 2-3 inches tall. It's not very big. It's very small, and it's pulling this kind of soil moisture, but we are building up aggregates, and we are actually getting some root growth out of it that allow for the water to move into the soil. So we're taking advantage of these rainfalls, getting it down to the soil and preserving it, as you can see in these lines here. So we have that soil moisture available in the spring next year. Some other strategies besides fall cover cropping, we had a whole bunch of acres that were spring wheat. So we do foundation seed in Minot for spring wheat. We took a harrow out there right after the harvest and harrowed it up because we knew that big rain was coming. We've seen that prediction. So that big rain from this chart here, we harrowed right before, 2-3 days before. I guess I don't have a picture of it. So we harrowed it 2 or 3 days, and then the spring wheat, actually the excess that flew out of the back of the combine flushed back up from that rain. So we took advantage of that fall rain and actually got a free cover crop out of it. All we had to do is figure out diesel fuel for running the harrow across the field. I'll talk about next is intercropping and broadcasting. So we've been doing some broadcast cover crops over at Minot, Dickinson, and Hettinger. And so broadcasting, we attach these things we bought off Amazon. They're just little simple seed spreaders. You spread grass seed. We zip tied them on the back of sprayers. We put rye, oats, and radish in different mixes on different plots, and we just really small seeds so we can get more seed in there. And then they're just remote operated. We turn them on, we get in the field. And so they're just throwing seed on the ground. So there's broadcast across the surface. And so we did this at the with Dr. Bartolone, Leo, if you heard of him. And so we did that R2 in rye, and then R5, or in soybeans, R2 growth stage, R5, we used rye, which was the most successful for establishment. Winter canola was a little bit harder. And then winter camelina was a little bit harder to get established, same with the radish. But here we got Minot, Hettinger, Dickinson. We can see the soybean yield, all pretty much the same within a site. So here's narrow row spacing of soybeans, wide row spacing. So within each site, relatively all the same yields. But the cover crop biomass from us going out there and broadcasting was the rye at the R2 stage. Here's that one line. We actually got good cover crop biomass, 300 plus pounds. And then also when rye put down with canola also got good biomass. The rye at the R5 soybean stage, we went out there. So the reason why we picked R2 and R5 is because we were already going out there to do either fungicide or herbicide application between R2 or R5. It was already part of our prescribed plan we were going with. So we just added that little small spreader on the back to get seed out there. So we didn't have to factor in another pass and additional fuel cost or trying to have a fancy interseeder to get these cover crops out during the soybean growing. So these soybeans were planted in the standard spring, and then we're putting out cover crops in June and July. So a lot of people always say, well, if you get so many pounds, are you actually getting coverage on the soil? So we're actually getting about 25 to 30% of the soil covered in Minot on the narrow row spacing, the wide row spacing, a little bit less soil coverage. But the reason why Dickinson and Hettinger had low biomass and low coverage of the ground is the cover crops just really didn't take off. So they're a much drier environment. So there's obviously a soil moisture gradient as you move from east being super wet to west being super dry. They were just so dry. We didn't have soil moisture sensor, soil moisture data right there. So they were dry, but this is taken fall, so it's not as accurate, but they were so dry during the summer, they just couldn't get them seeds, get seed soil contact with the water. They just couldn't take off. Or mine up, we got some of the lucky rains and we're able to see more success. And we've noticed as you move further east, the more success you have with it. So that's the other question when we get was like, okay, we're throwing this rye out there. It's growing at the R2 or the R5 with the soybeans. I already showed you the yield. It didn't impact the yield, but people are always like, what's the soil moisture? So in the fall, we went out there and did some soil moisture samples from 0 to 3 inches. We showed no significant difference no matter which treatment we had in soil moisture. So getting into a little bit of the economics of doing this. So the top in the red box is not factoring in any use of cost share programs. The bottom is the green box. So we'll focus on the Minot narrow row. So there's no cover crop. We spent $444 for the whole year for 1 acre. Then with rye, that's our return on investment. We made $444 with the rye because it cost us extra money to buy the rye seed. We figured it $419. We had to factor some extra herbicides and stuff. And so each additional cover crop, as we add more things to the mix, our return on investment went down a little bit because winter canola cost us a little bit more money. But then when we start factoring these cost share programs here, the $444 stays the same because there's no cost share because we didn't have cover crops. We had cover crops. And so we factored in $30 during that time. And so that way we got from $419, we went to $449. And the $30 is an average because there are different programs out there like Farmers for Soil Health. They do $25 your first year. And then there's some equip ones at $50, $70. And so we just went with $30 because there are different options out there. So here in the east part of the state, Hans Kendall did some work and he actually used an interseeder. So we were broadcasting because we didn't have special equipment. He did a little bit more interseeding. It's a little harder because you have to have the special equipment for it. But what was nice about the study is he had similar results to us. He actually was able to get the plants established and actually didn't see an effect on the soil moisture or the yield, just like us. So getting into a little bit of other factors. So these are some cover crops that you can use. So I just want to go over that because like the soil moisture story, I always want to talk about that. But then some other factors that can impact your soil moisture is saline and sodic in your soils. It's like I was mentioning earlier about different effects. So on this chart, we have normal soil, saline soil, sodic soil, saline and sodic. A lot of these numbers probably don't seem to mean a whole lot, but what you can think is green is the normal. So when we notice it's saline from chemical analysis, when your EC deviates away, and then sodic, we notice when the sodium absorption ratio deviates away or the pH starts to go up. And then if you have both, you'll have what's over here in the purple. So we went around and soil sampled. And so for instance, done with Naeem. So Naeem Kalwar and B and then Dr. Bortolone, we'll go around and help sample fields. We can go out to your fields if you have these troublesome areas that have saline or sodic you're predicting has that issue. And so we'll go around and we'll help sample them. So we'll do a 4-foot probe all the way down. We'll take several samples. We'll send them off to AgVi's lab, figure out all that kind of data we got back over here. Kind of know if you have saline sodic or if you have saline and sodic, make sure that's your actual issue. I also additionally do bulk density samples just because like I mentioned earlier, bulk density is an early sign of saline and sodic issues. So on our station here, we have 2 different fields that we outlined here that have a couple acres of each that had the saline issues. And so we went out there, we measured the soil, we did gypsum amendments. And so we got gypsum from some of the mines at Underwood to help remediate the soil back down a little bit. And then this mix is developed by Mr. Kalwar. Naeem, he has tall wheatgrass, slender wheatgrass, western wheatgrass, green wheatgrass, AC salt tender, make sure it's salt tolerant variety, Russian wild rye. And then we put winter hardy alfalfa. Sometimes people go in their second year planting this on these areas. So what we do is we go in, we make this, we square it off. We have this as the most affected area, and then we plant these species in there. Second year is maybe a little bit better for putting the alfalfa because sometimes the alfalfa just doesn't make the salt through real high. We always use barley and oats the first year when you're planting all these grasses as like a nurse crop, kind of like what Brady was talking about earlier to help get some of that stuff established. So you use oats and barley as a nurse crop to get it going. So all these natives and perennials will take off growing. We can put an alfalfa, drill it in the second year. Once the salt levels down a little bit, if you have real high salt levels. And so the intent was, because if we had annual crops, and so you're slowly, that area is going to grow bigger and bigger over time as the salts increase. trying to do is we're trying to do income protection. We're trying to reduce that area, make it as small as possible, but then try to find some little bit of value out of that instead of wasting money. We're trying to help increase the value. So if you're doing annual crop, you figure you're maybe doing $200 in inputs and you're getting no yield out of it because it's so saline, so you're not getting anything. So we squared that area off, and so cost to plant 1 acre costs about $100 for that mix if you do it all your first year. We figured we roughly made $33 return on investment the first year. And so bales in year 2, we started making a little bit more money because we started getting more bales as the alfalfa grew more and more. So we started baling it. I have one producer that I worked with, and they were this last year, they were only getting $8 a bale. Someone comes in and gives them $8 per bale of hay. They're only going to get 2 bales off of a 1 acre section. It's not super high, but their salt is super high, and the plants are starting to take off. But what they've seen the advantage of is their area is not growing. This has been a growing issue, the saline soda spot in their field. Instead of growing, it's actually getting slightly smaller. So they're happy because they're not losing more acres. They're just maintaining, and they found someone to take off the hay for them and get a little bit of money. Sometimes you can get some grants to put in cover crops, and that helps out and balance some of these costs. And so you can actually end up with a profit of $575, and the land is much better. Instead of losing money, spending $600. So the take home for saline soda areas, start on small critical areas. Like I said, us at Extension, just reach out to your local county extension office if you have one of these saline or sodic areas. We can help out. And then that publication they were talking about earlier talks a little bit more in depth about saline and sodic, and we can help kind of identify the areas, come up with a plan. And the purpose of it is to help reduce the erosion, remediate the salinity, and suppress weeds that are growing on the fringe edge of that and starting to creep into your field. So if you have other wet areas in a field, like slough areas, a lot of times towards the edges of them, you're trying to put something out there to help drive the moisture so that it doesn't creep and get wet spots and get your tractor stuck in the field. And so I've just sat down and looked at some different species, and we've planted them around some slough areas in Minot. And they did this about 3 years ago. They planted the slough areas with some of these different species. And we've seen some different success with different ones. And depending on how much moisture is in your slough area, how long your slough area is wet seasonally per year, kind of how successful which one's going to work. So I just found some native species to bring in. So these are warm seasons, these first 2. Switchgrass, Dakota is a native variety you can buy here. But if you have horse, sheep, or goats that are going to be feeding off it, is toxic. So you just up front need to know that. Prairie cordgrass is working really well for shorelines or areas, wet areas, or seasonally wet. But if your area is saturated more than half the year, this is probably not going to work in your prairie cordgrass. Red River is a species you could use, but it's not going to work in your area because it's too wet. Wheatgrass, which is also going to work with saline and sodic. The slender works really well with that, and it's Montana, Saskatchewan native. They have varieties from them that you can get. Tall and Western. Western's also a native. This is a cool season, so it's going to grow a little bit timing. So if you mix these together, you can get different timings of the year. Then I have 2 other species. I put these on a separate slide because canary grass and could be foxtail. So canary grass, if it has a lot of water, high moisture, it can actually become a little bit invasive, but it's native to Iowa and Minnesota. You can get the Reed variety. If you have high area, it could susceptible if it gets a lot of moisture. You're having that flooded areas flooded year round. You can actually get it a pretty good growth going. It can eventually become a little bit invasive if you're like butting up to a pasture, not necessarily an ag field. Same with the creeping foxtail. Garrison was introduced to North Dakota. This market is considered acclimated. It's not a native, but it works really well, but can get a little bit invasive if you let it go. And so my take home message here is just try something on small acres, small little piece of land, keeping the ground covered, lower the disturbance of the soil, keep a living root more of the year, increase the biodiversity. And so when we're talking about increasing the biodiversity, we're not saying like you need to have everything all at once. Just having soybeans, in this case, they use cereal rye for a cover crop, that's increasing your biodiversity. Going from a monoculture to 2 plants maybe. And then we kept a living root by having something growing in the fall and spring, a little bit in the winter cereal rye before it died off. And then we lowered disturbance. We went to a no-till system here. They're having some pretty good success, this producer, with their soybeans, and they're keeping the ground covered. In this field here, they've slowly noticed over time the organic matter is increasing, their soil, their aggregates are increasing, the water's actually moving better into their soil. They're actually reducing some of the areas that have been troublesome in the past for them for wet. Once again, my name is Chandler Gruener. I'm a soil health specialist and part of the soil health team. So a little more information. There's our soil health team. I'm the only one here today, but we have 2 other members. We have Carlos Pierres. He's a soil health specialist. He's in Fargo. We're both new. Me and him, we both started in April, May this year. We have Nadia Colwar located in Langdon. And the 3 of us together form a soil health team. We're building a soil health trailer. We're going around to different events like KMOT, Ag Expo, and other things. We're bringing these hands-on soil health demos. So look for us over the next spring and summer, bring these demos around to different events in the area. We'll actually have hands-on demonstrations to do. If there's any questions, I can answer them now. And then I also just include one extra slide in case I had a little extra time here. And so mine up this year, I planted hairy vetch, crimson clover, alfalfa, winter camelina, sorghum Sudan grass, and cereal rye. And so I planted them. I let them grow 95 days because that's all the more time I got from mid-August till my hard freeze November, sometime in early November. So I had a really low bulk density, I had a really ideal field there, bulk density of 1. I was only able to measure down to 31 inches. But even how small these plants are, so this plant, like the camelina is only about this tall. The crimson clover about 4 or 5 inches. The hairy vetch maybe got to 6. Sorghum Sudan was like the tallest at 7 or 8 inches. But even at 7, 8 inch tall plant above ground, so this black line here is roughly the soil surface. And we got actually the fine roots were found all the way down to 31 inches. So that's all the further deeper my probe could actually get and actually get that plants back out of the ground. We found fine roots in most of these plants getting down 20, 15. Even this camelina was only a couple inches tall, 9 inches for the solid taproot, 15 inches for the fine roots. So even if you have cover crops out there and you're like, man, this didn't do much, it's only this tall, it actually gets deep down into the soil. That's all I have. Thank you.